All right. We get the privilege of learning about complex numbers. Um, Complex numbers can be fairly complex, but mainly in the category of why do we need to learn this? Where do or where does anybody use complex numbers? So it's a pretty abstract concept. However, when looking at circuitry or the way that electricity moves and things like that, this is a large application of complex numbers. So if somebody were to go into electrical engineering, um, I'm sure they would use complex numbers quite often. And yeah, that is probably the largest use. So if you don't understand complex numbers, hopefully this will help you out, and hopefully it will at least allow you to appreciate it a little bit more, because we are all using complex numbers on a daily basis. When we pull that phone out of our pockets and text away or send messages in all the circuitry that's taking place, we all have complex numbers right in our pockets. So without further ado, when we are using complex numbers, this allows us to take the square root of negative numbers. So this is where we will be taking a look at some complex numbers. So let's start off. The equation x equals plus or minus the square root of negative 16 has no real solution because there are no real answers that when squared equal negative 16. But the equation does have solutions when a new set of numbers outside of the real numbers is introduced. The numbers are the imaginary numbers. So what is an imaginary number? An imaginary number is written in the form bi, where b is a real number and I is the imaginary unit. So we have I is a solution of x squared equals negative 1 because I squared is equal to negative 1 and I equals the square root of negative 1. Those are two key things to keep in mind as we're going through our lesson. I equals the square root of negative 1, so anytime we see a negative square root, we will replace that with I. Anytime we have a negative 1, we can replace that with I squared, or anytime we have I squared, we can replace that with negative 1. So the square root of a negative number is an imaginary number. Let's apply it. So we all know what the square root of 49 is. If we take a look at this first example, we would have negative 2. We know the square root of 49 of positive 49 would be 7. However, since we have a negative, we're going to say the square root of 49 I, and now I'll evaluate. So 49 is, or the square root of 49 is 7. Negative 2 times 7 would give me negative 14. And we would need that I on there as well. For the next one, before I even start to break this down, I'm just going to make this positive, and I'll attach the I right on there because we know the square root of a negative 1 is I. Now, if you think about 117, you might think, is that a prime number? Well, it is not. We could actually have any, or a couple multiples of 3. We could have a 3 in there, or a 9. If we divided by 9, we could have the square root of 9 and the square root of 13. 13 is a prime number, however, 9 would give us a positive 3. So our final answer for part B would be 3 square root of 13 I. Let us move on. Solve a quadratic equation with imaginary numbers. So we're going to look at x squared plus 25 is equal to 0. Write a solution in terms of I, and we will check the answers. So we have x squared plus 25 equals 0. We will subtract 25 from both sides. So we have x squared is equal to negative 25. Take the square root, take the square root. Remember, when we take the square root, we'll get that plus or minus. So we have x is equal to plus or minus the square root of negative 25. So let's make that positive and throw an I on there. And the last step would just be taking that actual square root. So x would be equal to plus or minus 5i. So if we're going to check our answers here, we could do 5i is equal to x. So from where we started, if I put a 5i in for that x, then that would be, here, let me go back to the top of the problem. I can do 5i squared, because I'm substituting for x, plus 25 equals 0. 5 squared is 25. I squared is negative 1, so that makes this negative, plus 25 equals 0, true. Let's deal with the negative 5i. Squared plus 25 equals 0. This will end up being the same thing, because negative 5 squared will give us 25, but I squared equals negative 1, so it'll give us a negative 25 plus 25. And again, that'll be equal to 0. Check, check. We're good there. All right, now jumping into complex numbers. An imaginary number is a part of a complex number. A complex number is a number which can be written in the form of a plus bi, where a and b are real numbers. So in a complex number, a is called the real part, b is called the imaginary part. Imagine that. If b is equal to 0, then the imaginary part is 0, and the number is just a real number. If a is equal to 0 and b is not equal to 0, then the real part is 0 and the number is just an imaginary number. So, a couple examples for you down there. Complex, we have them both together. Real, we don't have anything I. Imaginary, we don't have anything that's real. Should be pretty straightforward. Adding or subtracting complex numbers. To add or subtract complex numbers, add or subtract the real parts, and then add or subtract the imaginary parts. Again, that should be pretty self-explanatory too. So let's take a look at some of those. So for the first one, I'm going to add the real parts. So that's going to be 7 plus negative 2. Then I'm going to add the imaginary parts. 4i, or I guess they had it as 4 minus 5i. So we would have 5 plus, looks like a negative 1i, or 5 minus I would be our complex number there. For the second one, I'm going to have 5 minus 5, and then I will have negative 3 plus, because we're subtracting a negative. I'll make this I. So we're going to have a 0 here. Negative 3 plus 11 will give me 8. Plus 8i. So this isn't going to be complex. That is just going to be imaginary. Solve each equation, write the solutions in forms of a plus bi. So this would be solving any of our quadratics where we are taking a square root of a negative. So to solve that, we have to take the square root of both sides, Now we have x minus 3 is equal to plus or minus 2i. We're going to add 3. So x is equal to 3 plus or minus 2i. Next, let's take a look at this. Looks like we should be completing the square. So I'm going to get rid of that 18. X squared plus 8x is equal to negative 18. I'll cut that 8 in half, so that'd be 4, and square it, so plus 16 to both sides. That'll give me x plus 4 squared is equal to negative 2, square root. I don't know what the square root of 2 is, 1.3 something. Let's be a little more precise. 1.414. However, I'm just going to leave it as the square root of 2, and then I'll have an I. So plus or minus the square root of 2 with an I. That plus or minus is from taking the square root. I should have put that on there before. Subtract 4 from both sides. X is equal to negative 4 plus or minus square root of 2i. Okay. Let's move on. That's it. We're all good. Hope you guys learned something new about math that you didn't know before. I'm sure this is brand new for some of you. So again, since it's brand new, or I'm sure it's brand new for a lot of you, be sure to take your time. If you need to go back and see anything again, you always have the option to do so. Hope you have a great day.